Hello everyone, it's Brian from True Sustainability. I'm here at Mesa Community College and we're going to talk aquaponics systems today. And I'm going to go ahead and take you through a tour, and we're going to get started here pretty soon, and I'll introduce you to my guest, and we'll go ahead and take it from there. So his name is Dr. Brooks, and he is a marine biologist, and he has been working in the field for over 40 years, and so he's very knowledgeable on the subject, and we're gonna swing the camera over to him and get started with the tour.
Hey, how you doing? As he said, I'm Dr. George Brooks. I'm the teacher here at Mesa Community College in aquaponics. The class is called AGS 166, in case you ever want to look it up. Now, I have a degree in marine biology, that's true, but I also have a degree in air land aquaculture from the University of Arizona. That's where my PhD is from, and my bachelor's degree in zoology was from the Arizona State University. So I'm on both sides. You know, I'm on Sun Devil or on the Wildcat, depending on where the game is.
Right, right.
I'm now just going to kind of take you through a quick tour of what we're doing here. Now, this class was started in 2014. Peter Condon, who is the director of the Center for Sustainable Agriculture, gave me a call and said, hey, I want to set up a class on aquaponics. I'm glad he did. I don't know how he found me, but I'm glad he did. And so we put it together, and it's been going strongly ever since. And it continues to be one of the few classes that are actually accredited at a college in the United States. So with that information, let's get started here.
All right.
A basic aquaponics system is really, really simple. Now, it's something that's been done for like 5,000 years. People have been farming fish and plants together because it works. And they've been doing it for 5,000 years. You hear about the Aztecs doing it, and the Japanese and the Egyptians. It just keeps being reinvented for every age. And the most recent innovation to do the exact same thing, throw plants and fish together, was done by this gentleman, by Dr. Jim Rakosi at the University of Virgin Islands back in the 1980s, and they called it aquaponics. So integrated aquaculture, agriculture, that's the overall term. And so now let's see what it looks like today.
All right.
This is in front of us a very basic, what was called a media bed system. Now, how it works, now the overall concept is called recirculating aquaculture. That is, you have fish in a tank like this. So there's about, maybe 30 fish in here. I just put some new fish in here today. Unfortunately, they couldn't stay for pictures. They had to leave.
What kind of fish are you running in your tank?
All catfish.
All catfish.
All catfish. Now, a lot of people like tilapia, and I got my start with tilapia. I did my master's on tilapia, but they're cold sensitive, and it does get too cold for tilapia in Arizona. So you can't do anything with them for like until March. Catfish have a good temperature tolerance, and so therefore you can have them all year round. So we're growing catfish. And plus, catfish have a better fillet ratio. You get more catfish in fillet. So, anyway, I was raised on catfish. I like catfish. Okay, channel
right.
catfish. Anyway, recirculating aqua systems are all the same. You've got a fish tank, of course, for the fish. Then you fish poop, and so you have a thing that will take all the fish poop out of the water, and then the water goes through something called a biological filter that changes the ammonia that's left over after the fish poop is removed into plant food called nitrate, and then it comes back again. They're all the same. The innovation was that the nitrate turns into a poison when there's too much of it. But nitrate is plant food. So the innovation is we can just take all the nitrate out, grow plants, bring the clean water back to the fish, and that way in this arid land that we live in, there's no waste. If you don't do that, you gotta be pumping out about 20% of the water, or else it'll get toxic after a while.
Right. So that's a sustainability effort because you can keep using the same water.
Now, sustainability, you know, if it's not economically sound, it's not sustainable. If it's not socially sound, it's not sustainable. And if it's not environmentally sound, it's not sustainable. And so we are working toward becoming more and more sustainable at all times for the things that we do. Water conservation is just one issue. This thing is made out of a whole lot of plastic, okay? Plastics are not actually sustainable. Right now, they're the only thing we have. Someday, we may be able to work ourselves out of that into a more sustainable solution. Remember that term, sustainable solutions, because these are things that you can use to solve problems in a more sustainable way. So this whole idea is a sustainable solution for growing food in Phoenix Metro as an example that uses less water. So,
all right, let's go ahead and show us where the circulation happens, where everything is moved in the system.
So, the fish are in here. Water is flowing from a pump underneath there, and it was called a sump. It goes up, part of it goes into this right here. This is called a media bed. This is where we have this stuff here, which is called leca or hydroton, that the plants are growing in. The water circulates through here. There's a valve that makes this go up and down, so you always have oxygen. And they take all of the nitrate out of the water and bring it back to the fish. So it's just one big cycle, like I said before.
And how many times does that bed circulate every hour?
Every 5 to 10 minutes, every 5 to 7 minutes, it flushes. There's a valve here that kind of flushes the whole thing out every 5 or so minutes. So that would make it what? 5 into 60 is what? What is that? I'm too old for this.
5 into 60.
See, it got you too. But anyway, I think that's 12 times an hour. I think. Yes. Okay. That's 12. So 12 times an hour, this thing flushes up and down, and this is really good for the kinds of plants that need a solid substrate, something to hold on to. So you see in here we have this is some kind of spinach. This is fall student run. There's some kind of spinach in it. Lettuce, kale, tomatoes, beans, and there's a wide variety of other plants that are growing here, peppers, etc.
So, what would you not recommend growing in an aquaponic system?
There are a few sugarcane. Okay.
Sugarcane.
Sugarcane, fruit trees, things that are permanent. I wouldn't suggest growing, but things that are transient. You have them for a year, then you take them out and replant them. Things like that work well in an aquaponic system. People try to grow trees, and sometimes they succeed. But in my humble opinion, that's not really cost effective. The idea here is that you've got to be cost effective. These things are, aquaculture is a business. This is a method of aquaculture. Aquaponics is a method of aquaculture, and aquaculture is in general a business. So therefore it has to be cost effective for you to do so. Growing a tree is actually better in the soil than doing it in here. But in the things that we do, normally a garden growing this stuff, maybe you'll get for every square foot of room here, you get about a ½ pound a year of crop. Aquaponics can get between 3 and 10 pounds per square foot per year, depending on how densely you want to run. Okay,
so on a sustainability effort, you're going to get more food per square foot, is what he's saying to you, on an aquaponic system versus a regular soil-based system.
And that is where you begin to see the water savings, because you use the same amount of water whether it's in the soil or in here. But if you get 10 times the food, therefore you use 10 times less water per crop.
Right. And also these little balls and everything here can be recycled and reused several times. So that's another thing where you don't have to keep adding and adding and adding to the existing soil to continue to make it fertile. So let's talk about fertility for a minute here.
Yes.
Do you believe that the fertility in this aquaponic system is as good or healthy as a soil-based system?
Soil-based systems have certain advantages because there's a lot already built into the soil. We're working on getting it as good as soil. Soil is wonderful. We're working on getting ourselves to that point. I don't believe we're quite there yet, but we will get there eventually. Anything we have to make is not as good as nature, but we're getting there. That's the point.
All right.
But plus also, people think that our crops are plants and our crops are fish. No. Like in nature, our major crop is bacteria. In the soil, bacteria do all the work. They change one chemical to another so that the plants can take it up and the animals can eat it. That's the same thing that's true here. Other high density growth systems just use a chemical formula that does all the work. Here we have to grow the bacteria at the right proportion so that they create the fertility that is necessary for our plants to grow and our fish to have clean water. That's the primary difference. And also, the water is our soil. And so between fish, bacteria, and plants, that's what we grow.
All right. And those same microbes that are in the soil can be also present in the water. Is that
yes,
what
absolutely.
We're getting at?
That's what we're getting at. But the leca or something in the system have to provide a substrate, a place for the bacteria to grow. If you don't have it, you don't get enough bacteria to do the work. So in every recirculating system, there's something there that will allow those bacteria to grow en masse to clean the water.
All right, let's go ahead and move forward to the next system.
Okay. So
And
this greenhouse you see here is brand new. So we haven't done much with it yet, but we're getting there. Now this is called an NFT system. As I said, they're all the same. There's a fish tank. Then there is a device that takes all the fish poop out the water, called a clarifier. But then you have this place for the plants. In this case, it's called nutrient film technology because the water where the plants are planted rolls through these tubes. And we have the plants sitting in these pots. And the plants uptake the nutrients.
can you show me that one more time? Let's look at the root system on that.
Certainly. Okay. This is lettuce. It looks like a romaine lettuce. They're in these net pots. There's more of the leca inside of here. And the roots grow through into the water medium that's inside of these tubes.
All right.
Okay. So the water flows from here down there into a sump and then pumped back up here to flow through these pipes. Let the plants grow, let the roots expand, and then the water that is clean is back here into the fish tank. And again, there's about maybe 20 catfish in this growth tank. Now, one of the most important things is oxygen. Everything here takes a lot of oxygen. The fish take oxygen, the pumps take oxygen, take electricity, use power, but the roots need a lot of oxygen, and the bacteria need a lot of oxygen. It's called biological oxygen demand. And that means if you don't have a lot of air being pumped through this in some manner or form, your plants may not thrive the way they need to. Now there's more than one way besides air pumps to get air into the water, but that's what we use here.
Would you say that this system has more oxygen in it than the previous system?
No, we try to get as much as possible. We want to get a concentration of at least 6 parts per million.
Okay.
And we try to keep that as high as possible, while at the same time trying not to use too much power. Again, these things have to be economically sound, and the more electricity we use, the less sustainable it is. And we want these to be, if you need to put up a solar panel right here and run it all off the solar panel if someone wanted to. Now the thing that they don't say often, however, is that you can put a solar panel on it, but where's the power going to come from at night? You've got to have all this roll of batteries down there made out of lead and all kind of stuff. So there's the balancing. We've got a lot of work to do.
Yes, and solar systems continue to get better. And I like that you touched base on many different things, and it sounds to me like you monitor the system for many different things, probably pH balances, oxygen levels, just to name a few. Probably toxicity levels. I would assume all of that is being monitored.
We monitor everything. Every pound of food that comes out of here, we monitor. The only way you can understand what you're achieving is to monitor everything and compare and do the calculations as far as cost and effectiveness.
Yep, you know exactly how much food is being run, exactly how much everything's going to cost you, and be able to produce the maximum amount of food for the least amount of inputs.
Precisely. I have equations that aren't all that hard. You put it on an Excel sheet, it's just tedious. That I can tell you, if I put in X amount of food today, I'll have Y amount of pounds tomorrow of fish.
So that's what I really love about sustainability and the efforts that I've made on my own. Maybe it's on a much smaller scale at this point. I have not adapted my system into an aquaponics system. I just raise the tilapia, but I am making my own fish food, and that takes the input down quite a bit because you're basically getting the product for almost free. So there's a lot that can be learned by just using your brain a little bit longer and thinking, how can I do this with a little bit less?
Yes. Now let's move down to the next system while we still have time.
All right,
Now,
let's go ahead and do that.
You see your lettuce, you see beans, you see basil, you see chard, you see a money plant right here, lots of tomatoes, more chard. What are these? Peas? Got peas. It's a wonderful thing. But now this is something new.
All right, we want to hear something new.
Now, careful there. Now there is a type of aquaponics called deep water culture. That means that you have a pool of water where you have plants floating in rafts on that pool of water. I said everything's the same, it still recirculates through here. But the question is, how do we arrange all of those parts? And that's what's new here. As you see here, all of the parts are separate. We have a tank here and a clarifier here. In this, we put it all inside of one container, therefore reducing the cost significantly because we have no holes through the liner to leak so we don't lose water. This whole thing here is made from a kiddie pool. You can buy it off of the shelf, 7 feet wide and 10 feet long. And you buy it and get it from a big store that sends you stuff, through the mail, when it's stuck with an A. Okay, they have them on their shelves, usually. And so it makes everything easier to run and uses less electricity, less water. But it grows just as much food as anything else, perhaps even more. And this is, again, a new method of deep water aquaculture, deep water aquaponics. In this tank here, again, everything here is off the shelf as much as possible. You can either buy it in the big box store or order it in, or go to the local hydroponics store and buy an air pump. But this method was invented here in Phoenix specifically for our condition. So we have catfish in here. We have about 20 pounds of catfish in here. We're going to grow them to 30 pounds. Again, I can calculate exactly how much food and how long that will take to feed them every day. The water here is extra deep. It's 2 feet deep instead of 1 foot deep as in most deep water culture systems. That allows for more oxygen for the roots and everything else inside of here. If the power goes out, that's the major reason why these have been growing plants and not fish, because if the power goes out on these things, the fish can die if you don't get back with them in an hour, or you have to put on a backup system, on batteries and things. That costs even more money. There's a method in here, the way these tanks are designed. If the power goes out, the fish don't die, and the water still circulates through it for another 3 or 4 hours. It's not a panacea, but it has extended the amount of time that we have to get everything back together again. Here we use power all the time in this city. Thunderstorms, someone runs into a power pole. Power is the problem. The fish in here, I've lost 1 fish to a power outage. While in times in the past, I've lost 10, 12 pounds and other types of systems when the power went out. Very annoying coming to bury fish.
So let's talk for a moment, going a little bit back. Is the depth of the tank matters for a number of reasons. Now, the depth of the tank, does that affect the temperatures to be able to regulate the temperatures better?
Yes. It makes it more stable. The shallower the water, the more quickly the temperatures will change. Deep water acts as we call a heat sink. Water doesn't like to change temperature once you've got it to a temperature. So therefore, if you have twice the amount of water, it will hold the water for the heat for twice as long. So that's there. Deep water has more volume, so therefore it holds more oxygen. The deep water has more room for big plants spread their roots, such as these.
Wow, look at the size of those roots.
Oh, if you can see the tomatoes, it'd be twice this size.
That is amazing.
And the more room they have to spread, the more nutrients they can absorb to grow into plants. And most importantly, because doesn't use much energy, it doesn't have to pump water uphill. In fact, all the water is pumped by what's called an airlift pump. Air is pushed from here, it goes into this airlift pump, and it pumps water by air only. There's no electricity inside of here. That always worries me. There's no electricity inside of here. Air pumps water through this entire system at about 5 gallons a minute, all by itself. So in here we have lettuce, tomatoes, everything you saw over there. But I have done this system at home now for about 7 years, and I have grown up to 400 pounds per year in a tank this size. And now it's just a matter of how I want to manage it. If I go vertical, that I can actually get more. And this system is going to be used in the near future in something called the Phoenix Backyard Garden Program. The idea behind this program is for people now to take aquaponics from being in the school room but into backyard, where they can actually begin, if they're good farmers, it depends on whether they learn to be good farmers, they have the possibility of using this, and they're going to evaluate some other methods of raised bed. But if you can do it right, you can raise your food here, including fish. They're part of the crop rotation for less than it costs for you to buy it from the grocery store.
Significantly less.
That's the idea. But that's a matter of having good business model and good economics where you measure everything. Right now, that's a hypothesis.
And you also know what you're feeding your fish. So therefore, it's not going to have chemicals and additives in the foods. If you can get it all organic, so where your fish are nice and healthy, and they're going to have a completely different taste, a completely different texture by the way that you raise them.
That's true, if you can get that food at a reasonable cost. That's the challenge as far as these organic fish feeds are concerned. A plain old-fashioned fish feed that's gone into most aquaculture will cost you so much less. But then there is the question, exactly what are you feeding your fish?
Yep. And I've analyzed this portion quite a bit before I actually made my own fish food, and I use bugs as a main protein source in my organic fish food. I also grow my own plants to be able to harvest the leaves, dry them out, and make them into organic fish food. So I know exactly how much nutrients come from each plant. I also know how much protein that I can maximize with the bugs that I'm giving them, and they also can be dried and made into a fine powder where it's digestible for the fish. It's more water soluble, and it's a wonderful situation. So I can maybe trade some secrets of what I do with the food, so maybe they don't have to purchase quite as much food.
Well, the challenge you have, I'm glad you said quite as much. The challenge you have is a thing called scalability. When you start talking about tens to hundreds of pounds of fish, it becomes more difficult to produce that at home.
Correct.
And so that's the challenge we have, is scalability. So if each one of these growers is going to be producing 50 pounds of fish, they have to get, it's a 10-to-1 ratio here. Not 10 to 1. Every pound of catfish, you have to have 1.5 pounds of feed. Okay, so 50 pounds of catfish, that means, what is it, that 75 pounds of feed we have to have? Is that the right calculation?
Yes.
Okay, yes.
Yes, you're on the right track, and I'm really glad that you're touching base on that, because it brings up a big point of fish are on the absolute lowest scale, except for like if you were to consume bugs. That might be a little bit more sustainable, but what he's talking about is per pound of food. you have to feed the fish, or livestock, or different things. So as it goes up the chain, it's more and more food that they're required for. So like chickens would be the next one up from fish that take more, 3-to-1, and then the next one up from there would be pigs, which would be, I believe it's 5-to-1.
Yes.
And then the cattle is exponentially above that. So,
or even in fish, catfish and tilapia feed are the lowest. Tilapia is 1.3-to-1. Catfish 1.5-to-1. When we start getting up on top carnivores like striped bass and trout, it goes up to 2-to-1, etc., etc.
And also the growth rate is different, and also the environment is different for those fish.
Mm-hmm.
And so I took all of those things in account before I decided which kind of fish I wanted to raise for food and to be able to breed and all those things. The tilapia versus the catfish, I want to talk about that for a minute here. So I trust your knowledge and your judgment and how long you've been doing this. And I think flavor is definitely a big thing for you. I think preferring catfish over tilapia might be a palate thing as well, and also the temperature situation I agree completely with. But if you're able to regulate the temperature for the tilapia, or you're able to have maybe a deeper depth or a different type of tilapia that can withstand a little bit more temperature fluctuations, I personally have gone with tilapia for those reasons, because they grow really rapidly, and they also can reproduce quite a bit. So let's talk about that.
Well, yes, because you actually have hit on a lot of reasons why I chose catfish. Now I have been raising tilapia since 1980. I've raised a lot of tilapia, and everything all that glitters is not gold. Number one, flavor. Everyone looks at tilapia as one fish. It's not. It's 4 different fish. Each one of those fish have their own flavor. We just think it's one because we're hybridized them so much. They washed all the flavor out of them. But when you get down to the 4 different species that are primarily cultured in the United States, the kind of fish that you culture, you call them a blue Nile. They are a hybrid of the blue tilapia from Israel and the Nile tilapia from Egypt. They're 2 different fish, even though they are somewhat related enough that they can hybridize together easily. Their flesh is more of a tuna-like, and they grow really big, and they have very small heads, so they have a better fillet ratio, and they're more cold tolerant of the species. But there are 2 other species that come from equatorial Africa that are not cold tolerant. They have a bigger head, but they have a different flavor. The flavor is as different as a steelhead trout is from a kokanee salmon. Okay, people don't know that because we have washed all those flavors out. The next thing is reproduction. People think it's wonderful, they will breed so easy. However, if they spend all their time breeding it, they're not growing. And that's why you try to get as many of one sex as possible. And the process of getting one sex tilapia is not pretty.
Yes.
Okay. Sometimes in some places they use hormones to get all one sex of fish so that you don't breed, because when you're growing babies all day long, you're not growing the adults.
Yeah.
So that's the other problem with tilapia. Now, don't get me wrong. Again, I've grown 40 years of tilapia. But when I'm now trying to teach the subject, I want this to be as streamlined as possible. Finally, it's a cultural thing. The people who I will be teaching have a preference often for catfish, not for tilapia. Okay, they're raised with catfish all their lives. I was told that the tilapia is too bland. I like tilapia, but it doesn't have the same content, doesn't have the same texture, doesn't have the same flavor as a channel catfish. So this is the program I call Grow Your Menu. If you eat collard greens, you grow collard greens. But if you eat bok choy, you grow bok choy. Okay, the people that I work with will be working largely with collard greens and catfish. Now, but for my culture, I like collard greens. But bok choy grows just as well in here when the weather is cooler. The same thing is true with the fish. If the people who will be using this in this program, and I teach people here how, including the business, to grow fish in your backyard, so you actually grow it for less than it takes to go, so you have to get a profit from it. If you prefer tilapia, I will teach you how to grow tilapia.
And also, I just wanted to kind of ask you as well, is this is a very smaller system for the fish than like what I'm doing. Mine is 275 gallon tote, so it's going to have a certain amount of gallons that I can have a certain amount of fish in that tank, and so it's controllable more for temperatures and things like that. So when you're just raising a fish and not actually making it into an aquaponics system, there's some differences there, right? So like the inputs and stuff that you can do with your fish, you have to be careful about monitoring, what kind of things you put. You can't put pesticides on the plants. You have to be careful what ends up back into the water, right?
Yeah, that's called IPM, Integrated Pest Management. It's a whole science dedicated to what can we use where insecticides are your absolute last resort. So you have mechanical means, you have cultural means, all these different things to control pests. The idea isn't to eliminate pests, just get them down to the point where they don't bother you too much. It's called sub-economics. So yes, you're absolutely correct. Now as far as the bottled water, okay, there is 1,000 gallons of water in here. Okay, that's a good, it's also a nice even number for my students to work with. And that gives us a huge oxygen sink as well. But how much fish you can use is dependent upon how you use that water and flow it through your system.
So you wouldn't fill the whole thing with fish,
no,
right? Because that would be too many fish for this particular system, right?
No. The question is the question of how many fish you have is dependent upon how many plants that you have filtering the water. If you don't have enough plants in here to filter the water, you can only have so many pounds of fish. They are balanced. Okay, the fish produce the nutrients for the plants. If the fish produce more nutrients than the plants can use, that becomes toxic eventually. There has to be a balance. And it's one of the major challenges that we have in balancing this, and it causes you to have to be a good farmer to do this.
So would you say that it may be easier for people, if they're starting out, to maybe have two separate systems, like I do sometimes, where I will water my plants separately from the water that I have in my pond? And so I don't have those systems integrated together, but they benefit. Like the plants still benefit from the water that I give them from the fish, but I don't have to deal with contaminations. I don't have to deal with having specific measured amounts of everything. It's more of a scalable situation. Do you think it's more? It is sometimes a pain to have to use the water and take it from one system and then put it to another, but you can do that with maybe drip systems and then be able to refill the water up for the fish.
That's about a matter of design. Okay. As an example, this system is designed to do all of that. You can use the water as a compost tea and take it onto your trees. Every now and then you gotta change the water anyway because it gets too salty. Our water here is liquid rock. It's full of salt, evaporation, and it gets too salty to grow anything. You gotta put it somewhere. So put it on a tree because it's full of nutrients in your yard. All of these air tubes can be removed and put into buckets if you want to move fish around and things. It's designed to take care of all of those things. It's a matter of what you design for this system, for your system, to do. And again, there's the issue of scalability. If you have to move the water purposely from one point to another, that's taking your time to do that. You can build that in.
Yes.
Okay, you build that in, okay, if you want to.
So what would be your advice to someone just getting started with aquaponics?
Keep it super simple.
Keep it super simple.
Yep. And aquaponics is complex. There's no way around that. So anytime you add complexity to it, like having to manually move water from one point to another, you make it even more so.
Yes.
You make it more difficult to scale. And so you want to do something as simple as possible. Even though it looks simple, you want to make your system a lot like a Macintosh computer. Now that's a brand thing, sorry. But you look at a Macintosh and it's intuitive to work like that for most people. But the coding behind that screen is 10,000 miles long. The same thing is true here. No matter what method you use, you want to make it as simple as possible to harvest. You want to make it as simple as possible to feed the fish. You want to make it as simple as possible to harvest the fish. You want to make it as simple as possible to grow your tomatoes up. You want to make it as simple as possible to do all of the various things because they all cost you money. But the science behind it is huge to make it that simple. And I think it was Steve Jobs said that it's easier to make things look simple than it is to be simple. He said something to that thing. This looks simple, that looks simple, but there's a lot of science behind it. One last thing. You want to get multiple uses out of it. We can do more here than grow catfish, grow collard greens, or tomatoes and lettuce. We can also grow shrimp. But we're still working those details out. The reason why this deep water is here is that it allows us to have something growing down in here because we've got all this space that's being used for nothing except for those roots. Wouldn't it be wonderful if we could get another crop from underneath there? Something like giant freshwater shrimp as an example. Now they're from Indonesia. They're legal here, completely legal here. They're sustainable because they cannot reproduce or recruit. Their babies will not live in our environment, but the adults will. And they can get like this. So you can go to your local store right now and buy them from their native environment in Indonesia. I can go to my local store and the big tails, like quarter-pound tails, are like $17.99 a pound. And they grow here just fine. I did my dissertation on these things. But they got a problem. We tried them in here. I'll send you this. We tried to in here, and they eat all the roots. So we still got a little bit of work to do left on. But wouldn't that be wonderful to have an additional crop? You have your fish, you have your prawns, and you have all of this vegetable matter here that's all edible for people, making maximum use of your resource. You want to talk about sustainability? There's sustainability for you. Making total vertical use, not only going this way, but going vertical down just as well. So this is what we're trying to accomplish, to maximize the benefit while minimizing the cost.
Yep. So this is the wave of the future for growing, for eating and having food. We have so much food scarcity even in this country, and that shouldn't be the case. There's so many people that are struggling to have meals on their table and children that go hungry all the time. And so we need to think of these ways to do better and to have less inputs and maximize our yields and have healthy food for everyone, that they can have a little space of their own bit of natural, beautiful food that comes from nature. So I appreciate all the comments that have been made thus far and the time that's been taken for me. I just wanted to say thank you so much for being able to view this video. Hopefully you guys got something out of it. Thank you to Mesa Community College for their sustainability efforts, for doing all of these programs and being able to put awareness out there of different systems of growing food. And it makes you think outside of the box. You need to be educated and have a very basic stepping stone to be able to work off of, and you can learn and grow with it. So you can be very simple in your designs of whatever you're trying to do. And I just want you to understand that you are the change, you are sustainability. And thank you so much again for your time. And have a wonderful day, everyone, and stay tuned for other videos in the future.